What is up, y'all? This is our final review for the exam. Hope you're having a great time. Some of you are at home right now sleeping in. Bums, but that's okay. I'm not judging. We are going to get it rolling. Our first part of the final review. And today I've got Hans and Cam with us. And they're going to get us rolling with some questions. So we're going to go on the first one. We're going to go, by the way, a couple things actually before I get started. Number one, make sure that you know we're in the church building, okay, up at the top. Second, make sure you understand you can have a formula sheet. That formula sheet is online underneath the topics page entitled Final Review or Final Exam there. And then the third thing, just to kind of note, is that make sure you understand like one has with calculator and one is with no calculator. Just stay tuned on that. Make sure you got that. If you do, you're good to go. G to G. All right, let's do number 6. First, we'll go to that one on unit 1. So we'll say the unit and then we'll say the actual number. So unit 1, number 6, and then we'll go straight into number 7. And then we'll go from there. We're going to be bouncing around, and but let's go through those two first, and then we'll go from there. Okay. So with this one has x to the 4th minus 5x to the 3rd plus 8x squared. Okay, we've got all this here, right? And what we want to do is to try to simplify this as best we can, okay? Note we cannot use synthetic because of the fact that this is x squared. Now, if this was x plus 4, even though it says use long division, I don't care, just do whatever's easiest on the final. But because it has x squared plus 4, we can't use synthetic on this one. So and this is for anybody here, or even at home. You could even yell at your screen. What do I need to do on this in order to simplify? Is there anything that I need to kind of do to this problem in order to fill this in here? Anyone know? Yes, you at home, nicely done. It's x squared plus 4, and what you need to do is make sure you fill in the 0x. Does that make sense? Because if you don't fill in the 0x, it's gonna be a mess going forward. So so you have x squared plus 4, but make sure you fill in with a 0x, and then we'll go from there. Okay. All right. Now the question is, what times x squared gets me x to the 4th? So let me put that 0x right here. What times x squared gets me x to the 4th? Cam.
X squared.
Nicely done. Yes, it's x squared. So we're going to put x squared up on top. Notice, I like to keep all of the x squareds, like if I put a huge line down, that just to kind of keep everything aligned. I do that because if you get off kilter, it is easy to mess up. So that's just a heads up there. Okay. And by the way, guys, if you have a question or if something doesn't make sense, let me know. So what's x squared times x squared? Here we got x to the 4th. We got that. X squared times 0x is 0x to the 3rd, right? And x squared times 4 is 4x squared. Okay? Now, once I get to this point, I need to do something else. What is that one thing? Yeah, so these are positive, so we're going to change negative to be negative to be negative, right? So this first one's gone, so that's 0. The second one, negative 5 minus 0 is just negative 5, x to the 3rd. And 8x squared minus 4x squared is 4x squared. So we're going to keep that just like so, okay? And then we're going to bring down negative 20x. So we'll bring that down, bring her down. Yeah, that's right. So what we've got now is we've got the first part, and what we just did from the top all the way down to what's in yellow is what you're just going to do each time. So as I do this, it's just the same process. So if you can get the first part that I just did, you can continue. So like what times x squared gets me negative 5x to the 3rd? Yep, negative 5x. Notice it keeps going down, normally by 1. Sometimes it does skip 1, but notice it does go down. Negative 5x times x squared is negative 5x to the 3rd. Okay. Negative 5x times 0x is 0x squared. And negative 5x times 4 is negative 20x. Okay. What do I do next? Flip the signs. This is negative, plus. All right, so this first one's gone. The second one is 4x squared. Notice the third one is gone. Because of the fact that this is 4x squared here, though, I've got to fill this in with a 0x. If I don't, it's going to mess me up going forward. So just be careful. Now, yeah, I'll just leave it like that. So just make sure you fill that in, and you should be fine. Okay, what do I do next? Bring the 16 down. Good. And Hans, what would I do from here? Good. What times x squared gets me 4x squared? And we all know that that would be 4. So we'll leave that there. 4 times x squared is 4x squared. 4 times 0x is 0x. 4 times 4 we know is 16. Okay? Am I going too quick, guys, on that? So then we switch the signs. Boom, boom, and boom. This would cancel out here. This would be 0x on that side. And I brought it up here. And 16 minus 16 is 0. So really there's nothing because I already brought down that 16. So there is no remainder. If there was, I would just put r whatever, or you could put it over top of whatever the denominator would be there, x squared plus 4. But because there's no remainder, we can leave that there. So our answer would be x squared minus 5x plus 4. Just a heads up, what do we know if there's a remainder of 0?
It's a perfect square.
Yeah, kind of, sort of. I hear where you're coming from. Really what we're saying is if there's a remainder of 0, that means this is a factor or a solution. Does that make sense? Remember in, you'd see it a lot in synthetic. If I put 2 in and put all these numbers in, if I got a remainder at the end, that means 2 is a solution or a 0, right? And just a heads up, a 0 is the same as where it crosses the x-axis, right? Except if it's an imaginary number. I gave you a lot there, but hopefully that makes sense. Okay? Let's go to number 7. Number 7's a good one. I know this one can be kind of tough. The reason why it can be tough is, sorry. This. The reason why it can be tough is because it just has a lot of parts to it. So we want to get that down. So negative I times 1 minus 3i. Let's multiply that first before we multiply by 4 minus the square root of negative 36, okay? All right, so what's negative I times 1? Yep, negative I. And negative I times negative 3i is? We're sure on that? Because of the negative times the negative, right? Good, there you go, 3i squared. Now, I will tell you, this is one I would do 2, maybe even 3 times, depending on your time, you know, how you're doing with time on the exam, because this is easy to mess up on. We also know I squared is what? Negative 1. So what's negative 1 times 3? Good, so we could rewrite it as negative I minus 3. Okay, so we'll put that there. What about 4 minus square root of negative 36? What do I do with this? Square root of negative 36. What could I do on that one? Good, because of the negative inside of a square root, we bring it out as an I. And what we would put is that this is 6i. So this would be 4 minus 6i, and we'll put that down below. Okay. Now, since I already took care of those first 2, we can then multiply whatever we got here, which was this, multiply by 4 minus 6i. So let's do negative I times 4, which should get? Negative 4i. Good. Negative I times negative 6i is?
Plus
6i squared. Yep. Negative 3 times 4 is negative 12. And negative 3 times negative 6i. Yep. 18i. Money. Okay. Now, what can we do once we have all of that kind of laid out? What do we do now to simplify? Yep. Okay. So this would be what? What would this turn into? Good. Negative 6. So I would rewrite this. Negative 4i minus 6 minus 12 plus 8i. When we add and subtract like terms, what would we get?
14i minus 18.
Good, and a lot of times you'll see it more like this. Negative 18 plus 14i, where the whole number's first, imaginary number is second. Okay? Good stuff. Okay, so that's those two right there. Do you have any other ones at all? We'll keep going through, try to see. Just a heads up, while they're thinking about that, something to just remember at home. Remember on number 2, when you do synthetic division, to make sure that you put in the box whatever makes the bottom equal to 0. So because it's x minus 5 halves here, you would need to put 5 halves, positive 5 halves, in for the box in synthetic division. However, if I use one like number 5, where I say x equals 2 is one of the zeros, in this example, whatever I see is what I would put in. So here, you change the sign because there's x minus 5 halves, but if I give it to you, you keep whatever I give you, okay? You guys got one at all?
We do 10 on unit 1.
Yep, let's do 10 on unit 1. Keep kind of rolling there. All right, end behavior. Now with end behavior, one thing to kind of remember is this. We got kind of two things. You kind of remember the chart maybe. You'll see on the formula sheet, I'm not trying to trick you at all, but what will happen is I'll give you something that looks like this, and I'll say, I'm trying to remember. I don't want to say because it's a little bit different, but I would take a look at the formula sheet to make sure that you understand what it's saying. But one thing we know of is that when we look at number 10 is only focused on the one number and one variable with the highest degree. So everything else gets thrown out with end behavior. The only thing I'm focused on is this, negative 3x to the 6th. Okay, that's the only thing I'm focused on. Now, a couple things we know is this. If it's an even degree, both will rise or both will fall. If it's an odd degree, then we will go opposite, right? It'll be opposite, right? Rise right, fall left, or vice versa. Okay? Now, here's the easy thing to remember. If you could remember that even, both go up or both go down. Positive, both go up. Negative, both go down. Okay? So let's talk through that real quick. First off, on this one, it's even, right? The degree is even. Remember, the degree is the highest exponent. So since this is even, we know what will be my result. Both will go up or both will go down, right? So just so you kind of have an idea, we'll either say fall left, fall right, or we will say rise left, rise right. So we can determine whether it falls left and right or rises right or left and right by whether the number, we call it the lead coefficient, or the number that's in front of the highest degree. If that number is negative, think of someone who's negative, it's like frown, both will fall. So if this is negative, it will fall left, fall right. But if it was positive, both will rise left and rise right. Again, I'll give you those formulas. I would just kind of have an idea before you go in, because look at the formula sheet. It is a little different. So it won't just come out and tell you, right? You have to actually kind of know that a little bit, but there is some guide that is there. So we would say on this one would be what? Fall left and fall right. And we'll just leave it like that. Okay. Good stuff. Any other questions on that one? Or any of these? Y'all feel pretty good on number 9? Just in case, while y'all are figuring out one out there, I just want to put this one on there for those at home. Remember that anytime I find the y-intercept, I plug 0 in for x, okay? But if I find the x-intercept, I plug 0 in for y. Very good. So let's do like with the y-intercept. If I plug 0 in for x, I'd plug it in for this, right? Right here. So 0 plus 3 is 3. I square it. Don't multiply first, right? Square it to get 9. 9 times negative 4 is negative 36. Negative 36 plus 5 is negative 31. So you would say 0 comma negative 31. For the for the x-intercept, this is the tough part. Plug 0 in for y. So it should be 0 equals -4 times x plus 3 squared plus 5. So if I solved for x here, I could first, I have to kind of go backwards, right? I have to subtract 5, okay? Then what would I do? What would I do next? Well, I would want to divide that by -4, right? Okay, so that would be the goal, divided by -4. Is everyone good on that? That's here? Okay, perfect. So divide by -4. So what I have now is 5/4. I'll kind of come over on this side, do a different color so you can see. 5/4 equals x plus 3 squared. Now here's where the tough part comes. What would I do to get rid of this squared here? Square root. What I do to one side, I do to the other. But if I square root a squared, what happens to the left side?
That becomes 5/2.
Okay, yeah, good. And it's plus or minus, right? So if I square root a squared, plus or minus, so I should have x plus 3 equals, can I square root 5? Can I square root 4? Yes, I can. So I would say square root of 5 over 2, and that would have plus or minus. That makes sense there? And then I could subtract 3. So what I could put is -3 plus or minus square root of 5 over 2. See how that one's a little bit tougher? And I would say this, and then I would put comma 0, because again, it is an x-intercept. So we did this one and that one. That one was, from what I remember, one that was missed quite a bit on the exam last year. So just a heads up on that. All right, do y'all have any other questions? Just kind of throwing them out there. We can hop around.
Can we do number 2 on unit 2?
Unit 2, number 2, yes. So this one on number 2 says find all the zeros of the function, okay? Find all the zeros of the function. Now, this is a good one because on this one, it does say we can use our calculator, right? And I will tell you that there's one very, very similar to this on the actual exam, okay? So let's take a look at this one. All right, I do want to take out my calculator there. So be sure you have a calculator for tomorrow. That's a big deal tomorrow. Or on Wednesday, my fault. Okay, so first thing we're going to do is plug this in, okay? Because we can use a calculator, we can plug this in. So x to the 4th, and then plus 10, x to the 3rd. Just make sure I plug this in right, I think. Minus 10, x squared, plus 5x minus 66. Okay. All right, is everyone good on that? Now, when you graph this, you're going to see maybe you'll be able to see it. Maybe it'll be like mine, okay? Now, let's talk through just a couple of things in terms of how do I put this in terms of the graph so I can see it, okay? Now, if you do not know how to like change your window, I'm not going to be able to say much on the exam, okay? That's a big thing. So here's the kind of the steps that I take. I always go to Zoom standard first, okay? All right, I always start there. Sometimes it can see it, like right here, I can see part of it. Obviously, it doesn't help me much. Sometimes I can't. So in the case I can't see it, I'm going to then go to Zoom Fit. If you go to Zoom Fit, it should be, a lot of you, it's at 0. But I'm going to put Zoom Fit just to see what I can kind of get there. And as you can see, it looks as though there's like one about right in here, and it looks like there's one kind of out to the left. Do you see that? So just because I want to make sure I fit all of this in, I'm going to zoom out. And when I zoom out, you see this cursor? I'm going to zoom out. I'm just going to go to that left side. And what that does is when I press enter, it'll zoom out more towards that side than on the middle. And once I do that, I should be able to see something that looks more like that. You see it there? So what we've got here is, you hopefully can see it. I've got one on this left side and one on this right side that I'm trying to find. Okay? All right, questions yet? We're good? So how do I find what the x-intercept is? anytime you're trying to solve for something, max, min, x-intercept, go to second trace, okay? What do I go to next? 0, good. Remember that when I say left bound and right bound, if I'm trying to go after this x-intercept here, I want to be above or to the left of it. Y'all see that? So we're going to go to the left of it, press enter. And then when I go to the right of that 0, right, we want to go where? Past it, yes. So right here, if I went, like if I put it right here on this side, you see how that's not to the right of it? It would give me an error and I would have to do it again. So just in case, you know, just a heads up on that. So again, we'll go to the right side, press enter. And my guess can be somewhere in between those two. And if I put it there, I should be okay. And what you see is that negative 11 is my first 0, okay? All right, that's the first one. Now let's go to the same thing. Let's go to second trace again. Go to 0. This time, I'm going to go to the left of this 0 about right in here. So I'm going to go to the left side of it, press enter. And when I go to the right side, I want to make sure I go way up there because it's going to the right of that 1. And then guess, again, I'll go right straight through the field goal post there to get 2. So what we've got now is negative 2 and 11. Or I'm sorry, negative 11 and 2. Negative 11 and 2. Okay. Okay, guys, we good so far? Okay, so once I get to there, we want to take the rest of this. Let's see if I got. Sorry about that. Let's get this up and running. Okay, so now what can I do in order to find the other solutions? I've got these two zeros of negative 11 and 2. What can I do with those two? Yeah, synthetic, right? So I can use synthetic and plug them in to number 2 and go from there. So I'm going to plug in negative 11. What goes next to negative 11?
1,
Mm-hmm.
10,
Good.
negative 10,
Yep.
5, and negative 66.
Great, great, great. So what do I do now? What would I do now?
Bring the 1 down,
Good,
then multiply that by negative 11
good.
to get negative 1
Negative 1 there.
plus 11.
11. This would be 1, right? Negative 11. And then negative 6 and 66. That should be 0. If you did not get a remainder of 0, you either messed up in your the way we did the synthetic here, or something was wrong with your calculator. You might want to go back and make sure you plugged it in right. Okay, could be one of those two things. But if you got a remainder of 0, it's almost like this checked your answer and supported the fact that negative 11 is a 0. Okay, now don't start over from the simplified version, which is this one right here. What can we do to plug in another value? Well, since you got the 2 as well, let's plug in 2 to the top. So what do we just bring down the first one, multiply 2 times 1 to get 2, add to be 1, multiply to get 2, 3 times 2 is 6. Same thing the guys just did earlier to get a remainder of 0. Okay? So this just proved that negative 11 and 2 are really zeros or x-intercept solutions there. Okay? We all good so far? This is a longer one, I know, but it's, again, once you get the groove, we should be good. What does this turn into? Mm-hmm. X squared plus x plus 3. If you're confused, remember this is remainder. This number is by itself. I put an I there. This number is with an x squared. And if we kept going, we could go x to the third, fourth, and so on and so forth on that. So x squared plus x plus 3, I don't think I can factor that out. So how could I solve for the other solutions? This is a good one right here. What is this called again? Quadratic formula, right? Yeah, there you go. So what goes in for B? 1, so this would be negative 1 plus or minus square root. What does B squared turn into? 1, good, minus 4. What's A times C? 3, good, because 1 times 3 there. And then all over 2 times a is 1, okay? Now let's go inside the square root first. 4 times 3 is 12. 1 minus 12 is negative 11, good. Got 1, negative 1 plus or minus the square root of negative 11 all over 2. And anything else I can do with this?
Simplify the radical.
Yeah, can I simplify 11? No, there's no pairs, right? Yeah, but Cam's right. If you could simplify the radical, let's do it. Since this is a negative, make it positive and just bring an I out to the outside, and that would work. And I would just leave this value like this. So I'd have this. This is not an x-intercept, right? Because with an imaginary number, I can't have that. But we'll leave that there, and then we'll have negative 11 and then 2 as well, okay? So those 4 would be our solutions on that. Again, solutions doesn't mean it will be an x-intercept, but again, we kind of found where our 4 would be there. Okay? That's a good one. Other questions on another one you see?
What does number 4 say? I can't read it.
Let's see here. The one that says graph the following function?
Yeah.
So that one says graph the following function, include asymptotes and intercepts. So let's do that one. I think it's on here. Yeah. So we're looking at this one right here. Number 4, and this is y equals negative 3 to the x plus 2 power minus 1. Yes, I could see how that would be. It's a little tougher to see. Okay, so let's take out all types of transformations first, okay? So what are the transformations we can take out? So first off, except for, and I want to be careful on this, the only thing I'm going to leave in is this negative, okay? All right, remember that traditionally, a exponential graph will look something like this, okay? That's what it would look like. But what we know of is the fact that this x plus 2 does what to the graph? Or you could tell me what negative, yeah, this one goes left 2, I use arrows, right? Left 2, and what does the negative 1 tell me? Down 1. So really, once we graph this, we're going to need to transform it left 2 and down 1. Now, you could just use what you see in green up here, plug it in, get it out, graph it, and go. I prefer to do y equals negative 3 to the x power. And once I graph this, then I bring in where the transformations go, okay? What is the asymptote without any of these transformations? What is it traditionally of this? Without any transformations, what's the asymptote? Is it going to be horizontal or vertical? This one is actually going to be horizontal. Now, if it was a log, right? By the way, this is a side note. A log goes this way, right? You see how that one would be a vertical? So this is a log, whereas this is an exponential, okay? So traditionally, it's going to be at 0. So let's go through a couple things here as far as plugging values in, getting values out. What can we plug in for x? What are some good values?
Negative 1, 0, 1.
Yep, and 2 might be good just to put it in there as well, okay? So what we got negative 1, 0, 1, and 2. So let's plug in 2 first. Be careful, because what a lot of people will do is when you see negative 3 squared, they'll say, oh, it's negative 3 times negative 3, right? All right, traditionally you'd be right. If that was in parentheses, you could do that. But this is not, right? Because it's not in parentheses, you have to square the 3 first, then bring the negative in. So what would be 3 squared with a negative on the outside? Negative 9. Is everyone good on that? What about 1? What would 1 be? Negative 3. 0 would be?
1.
Negative 1. Good. Because 3 to the 0 is 1, with a negative is negative 1. What about negative 1? What's negative 3 to the negative first?
1/3.
Good. With a negative, right? So this would be negative 1 over 3. So am I done with this? Not. And in order not to confuse you, I'm going to take out this. This is what we had talked about earlier. We'll take that out. And let's just graph this first one in blue, okay? So we're going to graph this one in blue. So we'll have negative 1, negative 1/3 right here, 0, negative 1, 1, negative 3, and 2, negative 9, which is way down there. But you'll see something that looks like this. Again, where is the asymptote right now? Okay, this isn't an asymptote, right? This is the graph, okay? Where's the asymptote approaching? It's this dotted line right here. Do you see it? It's approaching this area. That's the asymptote right here, okay? And again, since it's there, it's normally right now at 0. Is this x equals or y equals 0? This is going to be y equals 0, and I'll show you why a little bit in a second, okay? So before we get to the final, we got one final one. Before we get to the asymptote and looking at that, let's look at where it's transformed. Again, now with whatever we find here, what do we transform all of these points to?
Left 2 and down 1.
Yep, so you just count over. 1, 2, down 1. It doesn't have to be perfect, but we can go left 2, down 1, left 2, down 1, and left 2, down 1. So this thing is going to go right here. Okay. What's the new asymptote?
Y equals negative 1.
Correct, because this right here, right? Was the line, but think of the line too as transforming left 2. If it goes left and right, is that going to change it? No. So left 2 doesn't impact it, but when it goes down 1, then what will happen is this thing is going to now be at y equals negative 1. The reason why I wanted to talk about the asymptote now is what is it crossing? The y-axis. That's why it's y equals negative 1. Does that make sense? If you want to think opposite, horizontal asymptote is y equals, vertical asymptote is x equals. Okay? Y'all good on that one? That was a good one. That was a real good one there too. Okay. Any other ones y'all see? Oh, it also said find the intercepts, didn't it? I just saw that too. So intercepts, if you looked at that, I think we already had one of them, right? Remember x-intercept, we plug 0 in for y. Y-intercept, you plug 0 in for x, okay? What we can do, remember this is where the graph was here, right? It went here, and it went this way. You probably don't, actually, let me do this. To see if I can go backwards to be able to see. There we go. Okay, where did it cross the, we're talking this one, right? The blue one was the first one. The red one's the new one here. Actually, let me do this. Let me do this. I don't want to confuse you. I want to make sure I do it right. Let's go, excuse me, let's go back and let's see what we've got here, okay? All right. First off, sorry, guys. And looking at that, does it cross the x-axis?
No.
It doesn't. So are there any x-intercepts? No. So I would graph first, and that way you have more sense on that, okay? Like what you do. For the y-intercept, what do I do on that? Y-intercept, we plug 0 in for? X. Good. So this one makes it a little bit easier. So if 0 goes in for x here, what's 0 plus 2?
2.
2. So I have negative 3 to the second minus 1. What does this equal?
9.
Negative 9, right? Because there's no parenthesis. Does that make sense? Kind of what we did earlier.
Oh,
You remember
yeah.
that? Okay, so you have negative 9 minus 1, which is negative 10. Good, 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 good. Okay. So you would, with the y-intercept, you'd plug 0, negative 10 in. That'd be my y-intercept. And x-intercept, you would just say nada, nacho cheese, whatever. I don't care what you put. Just no, it'd be nothing. Okay, for x-intercept. All right, got any other ones? Let's see here. Look at number 5, kind of the same idea. There is going to be one like number 5 on there. I think it is even a matching one. I know it's harder to see on your sheet maybe. But look at that real quick as far as that one goes. Question, is number 5 reflected? It is not, right? You might say, Coach, what are you talking about? Come back again. We're looking at number 5, right? You see on number 4 how that was reflected in the sense that 3 was negative. You remember the one we just did, right? Because 3 was negative, it went down this way. Do you see that one right there? Okay. You see what I'm saying? But let's say that it wasn't negative. Traditionally, it would go up this way, right? Okay. So I'm trying to help you out in terms of how do I pick which one it would be, right? Well, since it's going up the traditional way, right, from low to left to up to the right, are there any parts that are reflected? The answer should be no, right? Because a traditional graph, the first thing I would look at is, are there any parts that are reflected? If I got a graph that looked like this, I would automatically look for where is that value negative on that side, right? But because of the fact that you actually got a graph that looked like this, now it is lower, and I get that 100%. But since the graph rises kind of to the right on this side, we can automatically go to really 3 of them, right? Could be none of these, but it also could be 4 to the x minus 5 or 4 to the x plus 5, correct? Okay. Now, where's the asymptote on this one? On the one on number 5. It goes down -5, right? Okay, so if I were to graph this, right, it goes 1, 2, 3, 4, 5. It has one like this and then kind of goes up in this direction. Okay, so that's kind of the graph there down below. So which one? Yeah, why do you say A? And this is the A part, just so everyone knows. Why did you say A again? Because the 5 is negative, where would this be transformed to? Down 5. Good. So since it goes down 5, remember the asymptote, which is traditionally at 0, would go down 5. That's why it would be A. Okay? See how I use the process of elimination there? I'd rather I think 5 is easier than number 4. You know, I think 4, now with 5, the tough part is can't really give back partial credit, whereas 4, there's a lot of points to be had on number 4. So just a heads up on that. Okay? Okay, I know I'm jumping all around. I know y'all are. That's fine. 100% fine. Y'all have any other questions, just throw it to me. And by the way, if you're watching this review unit 1, on the review unit 2 that I'm going to do tomorrow, any ones that I did today, I'm not going to do on the review tomorrow. Okay, so just so you've got it if you are listening to this here. Any other ones at all? Unit 2, number 3. Yeah, we'll go there. Ooh, yeah, sketch the graph. That's a good one. Okay. Now, on the actual test, what I'm going to do is I'm going to give you on the side, kind of like how I did on the test, I will give you, like, what does it say? What is the horizontal asymptote, right? What is the vertical asymptote? What is the hole, right? Is there a hole? What is the intercept? And then kind of go from there. There's also a slant asymptote that's there. And there's also X, or hold up, did I say intercepts too? Yeah, you have the X and the Y intercept, okay? Now, all of these different parts are associated to this question, but what I'm gonna do is kind of piece them together. So I'll give you the list of them, Got me? And you'll just go step by step, all right? So let's talk about what we do first. And anytime we get one of these types of problems, what's the first step?
Simplify it.
Yeah, let's simplify by factoring, okay? Simplify this by factoring. And let's put that bottom in order. You see that? So x squared minus 7x plus 12. Let's just put that in order. Now, what does the factor of the top look like? What would that be factored to on the top? Good. What 2 when multiplied get me to negative 15, but when added get me 2?
3 and 5.
3 and 5. Good. And which one would be positive and negative or both? What would that be?
3 would be negative, 5 would be positive.
Good. Yeah. So again, these add up to be equal to 2, but multiplied equal to negative 15. What about the bottom one with 12 and negative 7?
4 and 3.
Good.
Negative 4, negative 3.
Good. Now, once I factor that, that's my first step. What would I do next in order to kind of maybe start filling in some of the gaps here?
Cancel the negative x minus 3.
X minus 3s we could cancel. So we automatically know that if I cancel something, what does that refer to? A whole. Good. So we'll put 3 in for the whole, but we've got to find what the y is of the whole, correct? And what we can do is rewrite this. The new version we're looking at is x plus 5 over x minus 4 equals y there. And what would I do to find what the y would be?
You plug it back in. Is it to the original?
Yeah, the 3 would go back, well, not to the original, the new one.
Okay.
The reason why is if it was to the original, you get 0 over 0, and if you did that, it wouldn't make any sense. So we plug it in back into the new one. Okay, we'll plug it back into the new one. And when I do that, I get what on the top?
8.
8, yep, over, what would be the value on the bottom? Negative 1, which would be negative 8, right? Okay, so we have 3 negative 8 as our whole. What do we know about something else? Hans, do you know of something that we could get there? We get intercepts, we could get vertical, horizontal, or slant, right? What do we know about the slant? Is there a slant on this one? It's a slant, right? If the top is 1 degree higher than the bottom, correct? What's the degree of the top?
So it's square to square. So
Correct. So there is none. One thing to remember is, can you have a slant and a horizontal?
no.
You cannot, right? Now, there are horizontal rules that I'm going to give to you on that formula sheet, okay? You have to know kind of how to decipher. I would be sure to check up on that, but I'm going to give that to you. What do we know about the horizontal here? Remember, horizontal would be y equals, vertical would be x equals. Remember, think opposite. Horizontal, you usually think, or I'm sorry, vertical up and down, you think y, but vertical is actually through the x, so it's x equals, whereas horizontal is y equals, okay? What would be the horizontal asymptote then? What's the degree of the top, you said? Good, and we'll just do the simplified one. It'll be the same thing, but it's 1 here, correct? What's the degree of the bottom? 1. If it's the same, and this is on your formula sheet so you can see it, if it's the same, we divide these two together, okay? If it's greater on the bottom than the top, 0. If it's greater on the top than the bottom, none. It tells you that on the formula sheet there. Again, if I was at home, I would just make sure I'm familiar with the formula sheet. You don't need to memorize that because I'll give it to you, but just be sure that you know what the formula sheet's saying so that it's easy to navigate, okay? So x over x produces what? 1, good. So y equals 1 would end up being my horizontal, okay? What do we know about vertical? Vertical is what makes the bottom equal to 0 because we call that undefined, right? So what would be the vertical asymptote? 4. Good. You're good. James joining the party?
Yeah.
We're podcasting. Doing a little podcast right now for you.
All right.
Doing it. So x equals 4 is that vertical asymptote, correct? So we've got most of it. Now we've got x and y intercept, right? Y-intercept means what? We plug 0 in 4? X, right? Okay, I'm going to do this on the bottom kind of right here. So this would be 0 plus 5, okay? Hans, are we good on this so far? Does that make sense? Actually, I'll do it in red just so you can kind of see it here. So it'd be y equals 0 plus 5 over 0 minus 4. Again, same thing we've been doing. Y-intercept, plug 0 in for x. And once I do that, I get what at the top?
5
Over?
-4.
Good. So 5 over -4 is my y-intercept, okay? If you put -5 over 4 and that's it, technically I should probably take off of that because you didn't put a point there. But I know what you're talking about. So if you did that, you'll be good. But really, I would like for you to put 0, -5/4. Okay? What about x-intercept? What do we know about x-intercept? So this is here. How do I find x-intercept on that?
Plugging in for y.
Good. So 0 equals x plus 5 over x minus 4. How do I figure out what the x would be equal to, x-intercept would be equal to?
Multiply by the bottom.
Yeah, if I multiply by the bottom, right, I get rid of it on one side. And if I do to the other side, what would happen?
It'd be equal to 0.
Yeah, this right here, if I did it here this way, right? This would be 0. So 0 would equal x plus 5. So what would be that value?
-5.
-5, right? Again, if you put it in as that, technically you should put it in as a point like this. But if you put -5 down, you'd be good. Okay? Now, a lot of different parts with this. I get that. A lot of different parts with this. Let's plug in what we know. Okay? So first off, we have -5, 0. Put that there. Next one, 0, -5/4, which is like -1.25. So we'll put it kind of in there. We have a horizontal that's at 1 across and a vertical that's at 4 this way. Okay? What do we know about this left side of this vertical? You can't have one that goes up and one that goes down, right? So what we can do is kind of go this way, can't we? We also have a hole at 3, -8, about right in there. So this thing's going to go down like this. Okay? Is anyone confused so far? Y'all pretty good?
Not so far.
Hans? Good question. Vertical asymptotes tied into what makes the bottom equal to 0. Okay? Now, I know what you're probably thinking, Coach, why did x minus 3 not become a vertical asymptote, right? Why can't I do that? Well, I canceled it out, right? So it can't be a hole and a vertical asymptote. So we would just put that, that's the hole that we put right here. You see that? And then so what we can do is on the right side of this vertical, correct? We assume, a lot of times we can assume that it's going to be at the top here. Like if it's down the bottom left, it's going to be at the top right. But just to be sure, so if you put in something like this without any like real points, I'd probably give it to you. But just to be sure, especially if you have some time on the test, plug in a value to the right of this vertical. So what's a good value just to plug in?
5.
5, 6, yeah, 7, something like that. So if I plugged in 5, I'd get 10, right? Over 5 minus 4, which is 1. So 10 over 1 is 10. So if I plugged in 5, I'd get 10. So you see how it's up here? I can then assume that it kind of goes down on that side and follows the same type of pattern here. Okay? If you have multiple vertical asymptotes, right? You remember that? You could have maybe 2. Split it up between 3 sections. And if you don't have like points, x-intercepts or y-intercepts in that, then you might have to plug in a couple values just to test it on that one, okay? I also noticed that you can use a calculator for this section, okay? It is very possible that you could check this with your calculator and use that and go forward. What I would recommend, though, is not banking on that. Again, some of this stuff you could find on this, but when you graph this on your calculator, it's not like it's going to give you a vertical asymptote and say, oh, the vertical asymptote is this, right? So being able to do this algebraically this way is necessary to find all of this stuff, okay? But the calculator might help you to be able to find that there. It's also important to note, especially for those of you at home, the ones that we have been doing, all these ones that we've done previous to this have a lot of work to be shown, right? Just note that you will get points back on any ones that you do show me and that you do. So make sure it's kind of more of a, yeah, I want you to get the answer right, but if you don't, if you mess up on something, show a lot of work. Show a lot of work on that, okay? Good stuff. All right, do we have any other ones? These are good ones right here.
Why are some of the problems highlighted and some aren't?
The ones highlighted are really good.
Can we do number 8 on unit 3?
Yeah, number 8, that's really good. Say it again. Oh, yes, yes. All of them are a free game. I will tell you the ones that are highlighted are like 99.9% sure they'll be on the exam. Does that make sense? So what I mean by that is do the whole review, but the ones I would really focus on are the highlighted ones, but that doesn't mean the other ones are not. That doesn't mean the other ones are not. Okay, so these ones are quick, but this is where some people can mess up. Okay, I'll just be honest, some people can mess up. So first thing, is A true or false?
True or false?
Can y'all see that on number 8?
Which one?
This is a non-calculator. There is a calculator, non-calculator section. This is non-calculator. And these are not like formulas. So it's not like, oh, there's formulas for this. This is more just remembering some of the rules. It's not, I don't want you to memorize them, but recognize the application of it, okay? Remember, anytime, first of all, if I think about this, right, a log of 1, what is the base of this? 10, right? Okay? That's just something to know. Anytime that there's a 1 on the outside, what does it equal?
0.
0 every time. So it does not matter. If the 1 is on the outside, it will always be 0. So this is true. Okay? All right, look at the next one. E to the ln of x. Okay? And again, does that equal x here? One thing to remember, what is the base of ln? E. Yeah, E does, right? Yeah. So if I do couple things, first off, ln, right? Ln of x, right? If I took e to that, these would cancel. Does that make sense? So this is actually true, right? E and ln are kryptonite, remember? If I had e to the x power, like this, and I took the ln of this side, right? What would that be equal to? X as well, because they, again, are the kryptonite. They kind of work against each other, right? And we can look at one a little bit later where that will make maybe some sense there, okay? Now look at the next one. This one is 6 to the power of log of 9. Again, what's the base of this? 10, right? Because there is no base. Do y'all see that? It's hard to see. There is no base under that log. Now, question. If I had 3 to the power of log base 3 of x, right? If it's 3 to the power of this, and these are the same, the log and 3 could cancel, giving me x. But if they are not the same, because this has a 10 and a 6, can they cancel? No, they cannot. So we would say in this example that this would actually be false, that it cannot be equal to 9. Now, if it was the same, then we could, okay?
As long as it cancels.
As long as it cancels, let's say I gave 6 to the power of log base 6 of 9, right? Because the 6 is the base of the exponent, right? 6 is the base of the log. If those two are the same, they do cancel. giving me 9. Okay. Look at this one here, log base 7 of 7. Are those the same? Is the base of 7 and the outside of 7 the same? Yes, they are. So guess what we could do? Cancel here. Little cancel party. Whoop, whoop. Give me 1 equals 1. And we know this would be true.
So for C, because it says in the directions correct to make it a true statement, could you just put 6 to the log base of 6, 9 equals 9?
Correct.
Yes,
You could switch that, a couple different ways.
Yeah.
That's what I would do though. Good stuff. Good stuff. All right. Other questions? What about number 9? Y'all get that one? You have to do this one without a calculator. Just a heads up here. What do we want to do on this one on number 9?
You want to get both sides to where they're 2.
We call it 1-to-1, the 1-to-1 property, meaning that that's not a formula. That's just to know. We want to get this 16 where it has a 2. All right. So 2 to what power is 16? 2 to the 4th. Good. So what do we do now? 2's cancel because, again, they are the same. So we get 4 equals 7x minus 5. How do I solve for x now?
Add 5.
Add 5 divided by 7 to get 9 over 7. Good. Good, good. Okay. Just want to make sure we got that. You see on number 1, the difference? The reason why I'm going back to number 1 is I just want everyone at home to see this too. This one says I can use a calculator on it, okay? It looks almost identical to the one I just did, but what's the problem about this one compared to the last one? Good. Can't make 5 into 3 and vice versa, right? So when this one, what would I have to do to solve for this one for x? How would I solve for x here? You could put it back to log form. Excellent. Very good. Okay. So how could I change it to log form? Good. 3 goes to the other side. What happens to the 5? That kind of gets bumped up too, right? Both get kind of bumped up. So 5x plus 1 stays on the left side, but the base of my exponent is the base of my log, right? Both of those are the same. So what number goes down here? 3. What number goes on the outside? Good. How do I solve for that right side then? Good. And you can do that. A couple ways you could do that. Some of you actually can plug that in. If you can't plug that in, you would say the log of the outside over the log of the inside. So you could plug it in as log of 5 divided by log of 3. And then once you do that, you'll get some decimal. And from there, it's a little bit easier to then solve for those. Yeah, subtract 1 divided by 5 to that number. You should get some decimal right there. Okay. All right. Is everyone good on that one? Good, good.
I have a question about the one that just finished.
Yes.
I thought that the exponents cancel too. So
I see.
it would have been 2 to the 4th plus 2 to the 7th.
Oh, okay. Yeah. They do not. Only if it's the same base, only those do, and we set the exponents equal to each other. Does that make sense? That's a good question. It's a very good question. Okay. Looking and seeing. Are y'all good on the log rules? Looking at those. Are y'all good with like expanding, condensing, all of that? Okay. Trying to see another one. What about number 4 on that same section? That's an easy one. I don't want y'all to miss that one. That one's a good one. E to the power of 2 ln of x plus 1. Could I cancel this here? Yeah, could I cancel that? I can't cancel that yet because E and ln aren't alone. That 2 is kind of getting in the way. Think of it as like a barrier. It's like offensive line. It's trying to block it from canceling out. Okay. What would I need to do with that 2?
I'll move it over to the other side.
Yeah, so that 2 kind of goes into my power, right? Called power rule. And I think I give you those rules. Make sure of that on the formula sheet. Hans, did I give you those formulas? I think I did. The log rules on there. Yes, I sure did. Good. I gave you an example of them. So just be sure you know how to apply them, right? That's the big thing. So this would be e to the power of ln of x plus 1 to the second. Can I cancel now? Yes, I can. So my answer would be x plus 1 to the second. Easy, easy, but I just don't want you to miss that because of a little error there. So just be careful of that one going forward. Okay? Number 5 of that one. Are y'all good with this? I'm just trying to get ones that I remember on the remember on there. Okay.
Are you gonna post the podcast?
I am. Sure am.
We're live, baby.
That's right. We are live and in charge. I don't know. I was trying to come up
Were you
with some
about to say
statement.
India? We are live in India.
No, Sweden. We are live in Sweden. Yes, we are. My home country. Yes, my home country. Okay. This is broadcasted in 6 different languages, actually, right now as we speak. I'm sorry. That's very bad. I'm sorry. My fault. I apologize. Any offensive remarks, I apologize. Okay, so let's talk about this really quick in terms of what does an ln graph look like, okay? So we know exponential. We already have this in the podcast, right? Start traditionally without any transformation, starts here and rises up, right? This has normally an exponential has a horizontal asymptote at y equals 0, right? And it changes and all of that. Okay. What does an ln or log graph look like? Well, this one goes up and down, correct? Now, notice this one does not say graph. It doesn't say. But it does say that you can use a calculator, so that may help. Okay, so you could use a calculator on this, but I'm going to show you how to do it without, just so that you can show work. One thing you got to know is that if it's on a calculator section and you choose not to show work, just know if you get it wrong, I can't give you credit. So just know that going forward. Okay, but this is what traditionally a graph of an ln or log looks like, right? So a couple things. This is what asymptote is this without any transformations? Vertical, and it's x equals 0. Got me? Right? Think of x, it's got to go through the x-axis if it's up and down. Okay? X equals 0's up and down. So a couple things to note though, all right? Because of this negative here, what was going this way, right, would go where? That negative would reflect it where?
Oh, over the x-axis?
Yeah, it would go over the x-axis, so it would look something like this. Something just to remember on that, okay? All right, so my expectation is that it will be what the green one is. Now, a couple things to kind of also go from there. What type of transformation would this be, since it's in parentheses? Would it be horizontal, or would it be vertical? Transformation. Would it go up and down or left and right?
Horizontal.
Horizontal, because it's inside, right? Good, Cam. Does that make sense? If you put, yeah, good guess. No, I'm just messing. If I had a +1 on the outside, right?
Yeah.
What would that be?
That'd be up.
It'd be up 1, right? Does that make sense?
Yeah.
On the one we did earlier, you guys were good on. It's because of the 3x minus 9, it throws you off. But because of the fact that it's inside parentheses, it still moves it left and right, correct? Now, question. This is just a heads up. Just talking through. Where would this go?
That'd go right.
Right 3, correct?
Yeah.
Would that make sense, Hans? Because that's in parentheses, or do you want me to re-explain that? You see that? Where would this go, Hans? So right 3 and up 2, correct? Okay, perfect. Now, the reason why I'm giving that to you is we set the inside equal to 0, do we not? Am I right? So what could we plug in for x to make this whole thing equal to 0? 3. Can you see that? If you can't see it, set it equal to 0 and solve. But we would say that the transformation would go where? Right 3. Because of the negative, we think opposite. Right 3. Okay? So if this thing goes right 3, what would be the new asymptote?
X equals 3.
Good, because this whole thing would be at 0, right?
Correct.
But now it's going to go to the right 3. So we're going to go 1, 2, 3. It's going to go up and down, right? And this new graph, which was green, now should be what's in white. Hopefully this isn't confusing you. The white part is what we are graphing, right? That we don't have to graph it, but that's where we're at. So we would say the asymptote is x equals 3. Okay? The other part it says is find the x-intercept, and we can do that by doing what? 0 goes in for? Which one, Hans? X-intercept, we plug 0 in for? Y. Great. So let's plug that in. So 0 equals negative ln of 3x minus 9. So someone help me out. What would I do with this to solve? Again, this is for my x-intercept here. 0 goes in for y.
Would you do the base E, cancel the ln?
Yes, we would, but let's make this change signs. Got me? So this would be negative 0, which doesn't matter, right?
Yeah.
So how do I get rid of ln?
Do the E.
E, good. So e to the 0, got me? And this would be e to the ln.
I lost you. Why'd you change signs?
Good question, because I can't do the e unless I get rid of that, make that positive.
Okay.
So if I change this and change this, I can do that as long as I do it to the other side. Negative 0 means nothing. And that's why I then take e to both sides. Okay? Someone put e to the 0 on their calculator real quick. See what you get. What would that be? This would cancel, right? So 3x minus 9, yeah, it'd be 1. So 1 equals then 3x minus 9. So what do I do to solve for x?
Add the 9.
Yep, add 9. Get 10 equals 3x. Divide by 3, divide by 3. 10/3 would be my x-intercept. You can just put 10/3, comma 0. You could put 3.33. You could put 3 1/3. I'll take all those. But that's how I would get my x-intercept. Okay? It's good. I believe on the exam, there is going to be a multiple choice with the ln as well. So the way that we did, do y'all remember the one we did earlier? The one we did on number 5 right here? One similar to that. Okay? So if you're at home studying, Sweden studying, or whether you're in here, I would just be sure to kind of have a better idea of what's going on. Make sense? Like what's going on with this ln graphs. So transformations, and then kind of go from there. Okay? It's a good one right there. Good one.
How do you find the intercept? Is it just on
The comma 0?
Yeah.
Good question. It's an x-intercept, right? So that means if it crosses at this spot, is there any y at all? No, there's not. We just put comma 0 and we're good. Okay? Wow. Went through a lot so far.
Oh, man.
Good, good, good. Any other questions y'all have? Numbers 10 and 11 are very similar. In fact, they're easier than the one we did. You remember the one we did earlier?
Oh, I do have a quick question.
Ooh, still with it, man.
Okay.
Yeah, go ahead. Absolutely.
For number 3 on unit 3, could you just cancel all the log base 8s out?
You can't. You got to first make that left side 1.
Okay.
Do you know how to do that?
Yeah.
How do you do that on that one? Number 8 right here.
So you do log of 8.
Or number 3 right here, right there. Yep, so we could say log base 8 of what?
2x plus 12. Could you do that?
Well, because these two right here are added, we could combine these together by our product rule. Do you remember that?
Yeah.
Where if there's an addition symbol separating, we can actually combine them and multiply them together.
Okay. So kind of 4 to
That's
And then
exactly
you cancel
exactly right.
bases and you just FOIL.
Now, once I yeah, that's right, James. So once I get here, now since I only have one log on either side, yes, then I could cancel. So now I've got 7 minus x times 3x plus 5. Because of the product rule, remember, okay, equals 24x. So distribute that. And then go from there. You want us to continue this just to make sure?
Yeah,
You want to do that? So we can FOIL this one out. Is everyone good at this point where we're at? Because again, product rule, you'll have that formula, just to application. So I've got 21x plus 35. Negative x times 3x is, yeah, negative 3x squared minus 5x equals 24x. Okay. Combine those together. Put it down here. I get negative 3x squared. 21 minus 5 is negative or positive 16x plus 35 equals 24x. Okay. I want to probably take all of this to the right side because of the fact that negative 3 is negative. We want that to be positive. Okay. Am I going too quick for anybody? Hans, how we doing? You good right now? We're good? Let me know if you didn't get this. Sorry, minus 35. Okay, so everything on this right side I combined to get 3x squared. 0 equals 3x squared. 24x minus 16x is 8x minus 35. Okay?
Is that the answer?
Not quite.
Oh, you have to factor it.
Yeah, we got to factor this here. Now, what you could do is you could put this in your calculator, see where it hits the x-axis, and then go from there because it's with the calculator part. But I believe it should be able to be factored somehow. So we know that if we were to check and guess, which you could do my A times C method, but if I put 3x and x here, you know it's probably going to be a 7 and a 5 somehow. So we want to try to kind of piece it together. And you could kind of see it. I'm going to put 7 here and 5 here. It could be flip-flopped. One's going to be positive. One's going to be negative. Which is positive, you think? Because this is positive 8, right?
50-50 shot 7.
You think this one's it right here? Okay. So let's try this. 7 times x is what?
7x.
Good. 3x times negative 5 is?
Negative 15x.
Good. So that would be combined would be negative 8, right? So that means that these would be flip-flopped. Okay. All right. So set them equal to 0. What would I get?
X equal to positive 7 over 3.
Yep. 7/3 and
Negative 5.
negative 5. Good. Now, this is kind of mean on me on this one. Remember, you can't have a negative log, right? You can't have like log of a negative. Just can't do it. Okay? So, because of that, which of these two values could I not have? Negative 5. Because if I plug negative 5, this one actually is okay. But if I plug negative 5 in for here, it'd be negative 15 plus 5, negative 10. So technically, this one cannot be the answer, only 7/3. Now, if you didn't do that on the test, I'm not sure if I'd take off a point or maybe I would just see your work and go from there. But it's just something to note. So when you get your answers, especially when you get 2 like we just did, see which one produces a negative and whatever one that would be, just throw that one out. Okay? Gotcha. I know that's annoying, but it's kind of how we do it. Are we good on the factoring and stuff? Are y'all good on that one? Remember, if you get stuck on that, don't spend forever and a day on that part. Since it's with a calculator, is what you see. Throw it in and see where it hits the x-intercept. Got me? And we're talking in terms of this down here once we get to this part. Don't do it up here because that might throw it off a little bit, but down here. Okay? Got it. Hans, you good? What part did you need me to explain again?
7 over 3.
Good question. If I set 3x minus 7 equal to 0, right? What would I do to get x by itself?
Okay.
Add 7, right? And then divide by
Where
3.
Where did that come from?
This right here was the factored version of what I had right here. Do you do A times C or do you do check and guess? Check and guess, that's fun. So once you have 3x and x here, right?
Right.
Here and here. Then you say what two numbers will multiply get me
Okay.
negative 35. You can just piece that together and kind of just try it out. That make sense? Again, trying to show all of the work flowing down. That's the biggest thing. You can show that work, that'd be huge there. Okay. Right now, we got pretty much through at least half of the review. Did a number of 4, 5, 6, 7, 10. I have down we did 13 so far. That's pretty good. We hopped around, I know. Do we have any maybe last one or two that we want to hit on that? And we'll hit on the other ones tomorrow as well, or tonight. You're coming to the rustic couch where it's very dark and
Bring your
candles.
flashlights.
Wait, what is that? What's the
Yes.
rustic couch?
Rustic couch tonight,
That's tonight.
4:30 to 6:30. Be there where we'll have
That's tempting.
fun.
That's real tempting.
Candles.
Wings and coffee.
That's right. Wings, coffee,
Why are you
fun. No sketchy things. Except if you're from Sweden, I don't think you can get a ticket in time to come all this way. But
Hey, but tomorrow we're at the rustic couch.
rustic couch
so If
tomorrow.
you're going from Sweden, maybe you can make it.
That's right. 3:30 to 5.
That's right.
Rustic couch. Tomorrow is wing special, but only boneless.
Oh,
lemon
yeah.
pepper.
Oh,
Lemon pepper wings, and then you can get a coffee with that. Sip a latte. Latte and wings. That's what I'm talking about. All right. Anybody, you have any other questions? Last minute ones? I want to do one more.
Yes, 6.
Cam's full of questions.
I love it. Let's-
Unit.
What unit?
6.
Unit 3-6. Okay.
I don't want to do.
Let's do that one. Oh, yeah. That one is a doozy. Okay. So on this one, LN, all right, this is all expanding, okay? Anytime I say expand or condense, go straight to your log rules. And by the way, whether it's ln or log has no difference on that. No difference whatsoever. So a couple things we need to know. Square root, what does that mean in terms of a power? Yeah, so I could rewrite this as this is going to be to the 1/2 power. Okay? So what do I do first? What could I do first on this?
Then you set it equal to 0 and then take the e.
Okay, so this is not solving. Do you see that? If it said
Oh,
solving, and
okay.
we'd have like, if we're solving for x, I'm trying to see if a good one that you were talking about.
Yeah.
I think I did one earlier, I think. I don't know if I've got one quite like that on there. I'm just trying to throw one out. Like number 5, we kind of did that on, where we're solving a little bit more. This is not not as much as solving one. We're just trying to expand this, right?
Yeah.
What do we know? First of all, this whole thing is to the 1/2, right? Let's get rid of that 1/2 first. And how do I do that? Not quite. It's okay. Good thought. Here's a hint. We kind of did it on number 4 on this one right here. What do we do with the 2?
Oh, you did the rule where you moved it to the front.
Yeah, we're trying to expand it, so we do the opposite, right? So we're going to go 1/2 ln of x over 3 over y, right? Okay. What's my next step? So this is step 1. What's step 2? If it's x to the third over y, yeah, so if they're dividing, what do we do? You sure? Look at your rule real quick. Look at that rule. When I have something divided, what do I do? Subtraction. So do you see how that's important? Again, you'll get the rules, just know where they're at. So it's 1/2 ln of x to the third minus 1/2 ln of y. Now, probably one of the most missed parts of this is from 2 to 3. A lot of people think they're done when they get to step 2, but we need to do one more thing. What's that? Say that again, Hans. Nope, because this is not set equal to 0, right? You see what I'm saying? We're not solving. So we're not going to take anything to the other side. We're just trying to expand what was on top, right? Here's a hint.
Move the 3 to the front.
Yep, do you see now I move the 3 to the front, making that 3/2 ln of x minus 1/2 ln y. Does that make sense? That was tough. Was that tougher? Tough one?
Yeah.
How about this? How about we do number 7? Because that one's kind of the opposite. So maybe that will help us kind of see. So condensing means we're trying to get it down. Expanding means we're trying to get it out, right? So 6 and 7 are kind of opposites of each other. Okay? Is that a tough one, Hans?
Oh, this has
Or on number 7? Number 7 stuff?
Oh, I remember this.
Okay. Let's try it out. I think it might be easier now that you've done one of those there. Okay. So we're trying to get this in terms of 1, correct?
Yeah.
Now, if I was trying to expand, you'll notice this is already expanded, right? Yeah. So basically, you could kind of say that these two are opposites of each other, kind of different problems there, okay? All right, I just put that in red so you could see it over the white there. But this is all 1, okay? What can I do first?
Isn't it like subtraction? You like divide or multiply or something? I forgot.
Yep. So division means it's kind of dividing, right? Plus means multiplication, right? But before I do that, you see the 2 in front and the 1/4 in front? Yeah. Remember, right? Those go to our exponents. All right. Let me stop right there. Are we good on that one?
You couldn't move the exponent to it.
Yeah, you're talking crazy talk.
Say that one more time.
Like, could you do 16 times 1/4 and put it in the front?
Oh, this like brought back here?
Yeah.
I can't because 16 is not an exponent.
Okay.
You see that? It's a value kind of like following the log, right? But if I do with the 2 or 16 or with the 1/4 and the 2, I could rewrite this as log base b of 16 to the 1/4 power minus log base b of 5 to the second plus log base b of 7. Okay? Is everyone good so far? All right. 5 squared is what?
25.
And we can fill that in because we can actually do that. So we'll put that in. If it was a variable, just keep it as x squared or whatever it would be. But we'll keep that at 25. What's 16 to the 1/4? That's probably
4 to the 4th, or 6, no, 16 to the 4th root.
yeah. So the 4th root of 16, that's the same as 1/4, right? So that would be what number? So just in case you at home can't see that, that'd be the 4th root of 16. Or what number multiplied by itself 4 times gets me 16? Be 2. Very good. So we can rewrite this as log base b of 2 minus log base b of 25 plus log base b of 7. Okay? You got that was the hard part. This is the easy part now. What happens when I divide? First of all, we're only going to have 1 log base b, right? We know that. What does it mean if we have subtraction?
You
Divide it. Which one's on top? 2. Good. Over, and what's on the bottom?
25.
Good. Okay. What if we say plus? What does that mean about this 7? Is it going to be on top or bottom? Top, because we know addition, multiplication, right? It means multiplication there. All right. So this would be log base b of, would be at the top?
14 over 25.
14 over 25 That'd be great.
Bang, cut the podcast off, we're done.
That makes sense?
Bang,
Cut the track.
cut the track.
All right.
See you off the rustic couch tonight, yeah.
Rustic couch. That's right. Candles, wings, coffee.
Cam's gonna be there.
Cam's going to be there. Going to be having some fun at the rustic couch.
Yeah.
That sounds. I never thought that was creepy until y'all said in y'all's class. They're like, no one else thought it was creepy until y'all said that. Hey, have a great time. This is review again. Part 1. Tomorrow we will get part 2. Remember the rustic couch tonight, where all dreams come true.
Baby.
Yes. And then 7:30 tonight, the movie. If you want to come and see that. If you're lame, you won't come. But
Guardians of the Galaxy too.
it'd be good times. Anyway, hope you have a good one there. All 0 viewers of you, and but we do have 3 here. 3 right here. Thanks to our sponsors today, AT&T and GHC, of course, and the annual fund, sponsored by the annual fund. So donate. Have a great one. We'll talk to y'all later.